Let's try to clear up the mystery of blood transfusions and transfusion reactions and those other things that will get you fired on the spot if you ever do it. So we need to talk about blood type. We're talking about the ABO type. I'm not going to talk about the RH, which is the positive or negative. I just want to cover what's called the ABO system, all right? So blood type depends on what are called antigens. Now we're going to talk a lot more about antigens when we get to the immune system. It stands for antibody generator. But for right now, just think of antigens as little markers that are on the cell. So if you have type A blood, it's called type A because on your red blood cell you have the A antigen. This is like a little glycoprotein or something. Who cares? But it's identical. Your body can see it. Your body can recognize it, okay? If you have type B blood, you're called type B because you have the B antigen. You're born with it. All your blood cells, all the blood cells in your body have the B antigen. Now some people are born with both the A antigen and the B antigen on all their red blood cells. So what do you suppose we should call them? Oh, those clever scientists, they decided to call them type AB. Then there are some people who are born with no antigens on their red blood cells. And so what should we call them? Well, they have none, so we could call them type none, but instead, the people would get confused, think they were like priests or something, nuns. So instead we call them type O. It really should be type 0, shouldn't it, since they have 0? But the problem is they use letters over here, so they felt like they should still use letters over here. But O is 0, because you have 0 antigens, okay? So those are the 4 ABO blood types. Type A have the A antigen, type B has the B antigen, type AB has both. Lucky, you're special, you have both. And poor type O have no antigens, okay? Now, what happens then is in your blood plasma, you are also born with antibodies. Now what do antibodies do? We'll cover that when we get to the immune system. For right now, I'm going to say that antibodies attack antigens. They don't really attack them, they handcuff them, that's what it comes down to. But for right now, that's good enough to think about. Think about it as though the antibodies are going to attack the antigens. So as it turns out, if you're born with type A blood, you have the A antigen on your red blood cells. You're also born with antibodies in your plasma that are anti-B antibodies. They will attack the B antigen. Are you in any danger of them? No, you're not, because you have the A antigen on your red blood cells, so these things can't bother you. Then people who are born with type B blood, they have the B antigen. In their plasma, they have anti-A antibodies. See, they would attack the A antigen. But fortunately, these people have the B antigen, so they're safe. Now then, people with type AB blood have both antigens on their red blood cells, so what antibodies could they possibly have? None. If they had either of these antibodies, they would be attacking their own blood. See what I'm saying? You can't do that. You can't have any antibodies. You would be attacking your own red blood cells. And then the people with type O, here's where they get to have their special moment. They didn't get to have any antigens, but they have both kinds of antibodies, anti-A and anti-B. Notice, basically, your plasma antibodies are like the opposite of what your type was. If you have A antigen, you have the opposite B antibodies, anti-B. If you have the B antigen, you have the anti-A. If you have both antigens, then you have the opposite in your plasma, which is none. If you don't have any antigens, then you have the opposite in your plasma, which is both. So now all we have to do is whenever we want to figure out if it's okay to transfuse someone's blood into somebody else, we just have to think, here is the person we're going to be transfusing from, here's the person we're transfusing into. Because we're going to put their red blood cells into these people's plasma. So all you have to do is look and see, is it going to work or not? Suppose you wanted to put type AB blood into the body of somebody who had type B blood, all right? So the donor is type AB, the recipient is type B. Is this going to work? Well, let's think about it. You're going to take AB red blood cells that have A and B antigens, you're going to put them into the blood of a person who has anti-A antibodies. What's going to happen the moment you put this kind of blood into this person? Their antibodies are going to attack it. And now you get a blood transfusion reaction and you lose your job forever. They will never hire you again. So you always have to watch out. You can't ever put blood into somebody who has antibodies that are going to attack that blood. Do you see how easy this is? I mean, come on. There's nothing to it. Just match them up and see if it's going to work, all right? Let's try again. Suppose we want to put type O blood into somebody who has type A blood. Is this going to work? Well, type O has no antigens. These people have anti-B. Does it matter that they have anti-B? No, because there's nothing to attack, is there? So therefore, this is going to be okay. This is okay. It's going to be just fine. As a matter of fact, look what happens if we take type O and try to put it into type B. They have antibodies against A, but O doesn't have any antigens, so this is going to be okay too, isn't it? And what if we take type O blood and try to put it into somebody who's AB? Well, they don't have any antibodies, and type O doesn't have any antigens, so this is okay as well. So can you see why type O is called the universal donor? Since it doesn't have any antigens, it doesn't matter what people have in their plasma, there's nothing to attack. See how easy this is? It's just a matter of looking to see, look at the antigens on the red blood cell, look at the antibodies in the plasma, and just make sure they don't clobber each other, all right? So let's try a couple more here. Oh, that was cute and wonderful. Yeah, crap. Like, who cares? Like, anybody actually cares whether these lines are straight. All the OCD people do. Let's say you want to put type A into type AB. What do you think? Is this going to work? Well, type A has the A antigen. What about type AB people? They don't have any antibodies. Therefore, this is going to be okay. Right? What happens if you try to put type A into a type B person? Well, that's not going to work, is it? If you put type A into a type B person, type A blood has the A antigen. People with type B have anti-A antibodies. So the anti-A antibodies are going to attack the A antigen. So this is bad. Bad. Don't do that. You might kill that person. All right? See? You can't put type A into type B because they've got antibodies that will attack the type A blood. But let's say we want to put, so we already found out we can put type B into type AB. What if we want to put type B into type AB? What's going to happen here? Well, type B has the B antigen, type AB has no antibodies, so this is going to be okay as well. And then what's going to happen if we try to put type O into type AB? Well, O has no antigens, type AB has no antibodies, so this is okay too, isn't it? So therefore, can you see why type AB is called the universal recipient? They can take anybody's blood, and you know that right away just by looking at the fact that they have no antibodies. So they don't have anything to attack anybody's blood. So you can put any kind of blood into a type AB person, okay? So, do you see how this works? It's really not difficult at all. In each case, you just have to look. The blood from the donor, look at the antigens. The blood from the recipient, look at the antibodies. As long as the recipient doesn't have antibodies that attack the antigens of the donor, you're going to be just fine, okay? Let's try one more. I don't remember what ones I've tried already and what ones I haven't. What if we try to put type A into type O? What do you think? Well, type A has the A antigen. Type O has anti-A antibodies. No, this is bad. This will not work. All right? Once again, all you have to do, the donor, the recipient. Look at the antigens on the donor, look at the antibodies in the recipient. If you have antibodies that are going to attack the antigen, then it doesn't work. If you don't, then it's going to be just fine. I've seen these charts like online where they have like it's a big table of the blood types going this way, A, B, A, B, O, A, B, A, B, O, and then they have the boxes, all the squares, and it's like, check or X or check or X. And I've seen people like try to memorize that. Oh my God, what an incredible waste of time. You can solve any blood transfusion problem just by thinking about what are the antigens, what are the antibodies. You just got to make sure there aren't antibodies that are going to clobber the antigen. So you don't need any tables or charts. You can figure these out anytime you need to, all right? Text or email me with questions.